So the drafting process is quite interesting. Let's kill this. Well, maybe not. We'll just do this. Okay. So first, hi, I'm Chuck, and I'm a calcoholic.
Hi, Chuck.
So,
are you recovering?
And to tell you how hardcore, and then I couldn't make this up. So my dad had a an HP 45 my senior year in high school, and I liked it, and it was pretty neat. And I worked my entire summer between senior year in high school and freshman in college to save up for part of the cost of an HP 65, and I had to borrow the rest from parents. I used that throughout college. When I went to the freshman mixer at Virginia Tech, in the double E mixer, someone asked me, well, what do you want to get out of school? And I said, well, I'd really like to understand how these calculators work. Okay, well, 6 years, a BS in double E, an MS in double E, and an MS in computer science later, I had a little bit more of a clue, but I still wasn't quite there. So I interviewed in a number of different places. One of them was in Corvallis. I was at Ohio State for my master's, so I went during winter break. I couldn't make this up. When I went out to my car to catch my flight, I couldn't find my car. It had been snow plowed under. The snow completely covered the car, and I had to dig it out. And it was minus 40 degrees with wind chill. Okay, I arrived in Corvallis. Okay, it was 65 degrees and sunny. It did not rain any of the time I was in Corvallis. Wow. And I was in my down jacket, looking around, and yeah, I get this. This could be good. All during the meeting, they said, it's not like this normally, it usually rains. But I was sold. It was sold before with calculators, but then when I got out there and saw it, it was good. But enough of me. In my interviews, one of the people that interviewed me was a quality engineer. He held up an HP 41C. And he said, try it, and I tried it, and it worked, and that kind of stuff. He says, now let me show you something. And he reaches over and grabs a piece of Scotch tape out of a Scotch tape dispenser, pulls it out, and clips it off, just regular Scotch tape. He drew that across the top of the 41C. Never touched the unit with the tape, and it locked it up. It latched it up. And he says, this was one of the one of our jobs is that we have to build a robust product and latch up in CMOS. CMOS was new at the time. This is 80. This latch up was a big deal, and so one of the things they had to do on the product before they released it was fix it for that. So that was my first introduction to, well, it's not just how you design it, but how you put it all together. The last person at the end of the day that I talked to was Bernie Muse. She was the lab manager. Bernie had, have you guys ever been in an auto parts shop where they've had like empty batteries, car batteries? Yes. The blanks? Okay, he had a car battery on his desk, and glued to the top of it was a 41C with a card reader. Okay, and I said, what is this, Bernie?
Are you talking about Bernie Muse?
Yeah, this is Bernie. He had this on his desk. And I said, well, what is this? And he says, well, that was a gift from my marketing department. It turns out that the 41C card reader chewed up a lot of battery. It's like when they put a card through, it was like they saw the battery level go to 0 pretty quick. And so the marketing department, to remind him of the importance of doing battery life stuff, gave him this car battery with this and said, this is what you're doing to us. So I joined when I arrived. By the way, at the end of the day, he said, well, you did okay in your interviews. We'll probably have you do firmware, because I focused on computer science and double E. I arrived. They said, we'd like you to meet Bob Livengood. You're going to be doing ASIC design, hardware design. and I had not had a hardware design course. Okay, not a CMOS IC design course. Okay, I spent my first 4 months doing continuity checks. We had paper schematics, and we had Mylar artwork plots, and we had yellow highlighters for the schematics, and we had color pencils for the Mylar plots. And all we did was we looked for the NAND gate and looked for that. And that was probably one of the best ways to learn some of the design, because these designs originally came from HP Labs, and these guys were awesomely creative. They had 3 transistor NANDs, 3 transistor NORs, they had 4 transistor exclusive ORs, they had basically all sorts of really cool transmission gates. They had and inverts for probably talking stuff that most of you guys don't care about, but really clever stuff on the EE side. And by just going through that, I learned how to convert the digital logic, which I understood, into the IC stuff. So I was a small part of the 75 team, just to be clear. I worked on the display driver for the 75. It was, to tell you how simple it was basically a dynamic shift register with about 12 bits that was controlling transmission gates that switched between the different high voltages that were required for the LCD. So it was a trivial little chip. For me, it was my first one, and it was a big deal. It didn't compare to the RU chip, which was the garbage chip that Tim Myers and folks worked on, or the ROM that had its own address incrementing logic that we talked about that Bruce Schober worked on, or Liz Wogan, which is now Myers. It did compare to the analog chip that was the card reader that Tom Arnold and crew worked on. Really impressive. For the time, it was state-of-the-art CMOS logic. I was just doing this little display controller. Okay, so then I went on to, so we finished up the 75 and we got that out. And we had a customer, you guys know it's not a secret, it was AT&T, that said, well, we like the 75, but we really need a modem and we really need more memory. So for those of you that are 75 aficionados, you'll know the 65 address space was 64K. Okay, of that, the first 32K was ROM, then the next 24K was RAM. Of that RAM, 16 was built in, and there was a massive 8K memory module that you plugged in to expand it up to 24K, and then there was another 8K of ROM on the top. And that was the entire address space. Well, we filled that up completely with the base unit. Okay, the modules were basically bank switched in. Okay, the ones in the front. The 75 was, as was pointed out earlier, was a leverage architecturally of the 85. So it was a little long in tooth, and the firmware is good firmware, but it's not near as fancy as the 71 stuff, as you guys that probably are all aware. So when they said we want more memory, that was somewhat problematic because there wasn't any more place to put memory. Okay, so we designed a pod. I have one. I'm taking it apart. And what the pod was this thing. Okay, so it was a Novation modem. Those were the guys that did the 100 baud modems at the time. There was the PQFP here is what we call the Mimic IC. And basically what this was is, all it was basically a set of mailboxes that allowed you to write into up to 64K more of RAM out here that you could store as a CMOS hard disk. In addition, there was a ROM, the Mimic ROM, which had all the code in it that allowed the BASIC to access the expanded memory and the modem. So that's the system. Okay, it's not real complicated and whatnot. It's sort of a kludge, but it was a kludge that worked and it came together on time and whatnot. So the way mechanically this puppy worked is you took the battery door off the back of the 75, you dropped the 75 on, you bolted it down this way, okay, and then there were 2 batteries on the bottom, and there was connections in here on the PC board to connect up the 2 batteries to the 75. You needed the second battery and whatnot for the modem. Okay, so we built this puppy. It worked. We got it out in the field, and we had some problems to begin with. These units were resetting. Okay, and so we did all sorts of stuff to try to figure out what. I mean, if you look at the unit, there's a metal plate on that the 75 sits on. There's a metal plate on the bottom. That's part of ESD. We've got shielding on the place where it plugs in. And so we thought for sure that what was going on was it was some sort of ESD event or something like that out in the field. Okay. Well, just to help people remember, you gotta look at how your customers are using your product. Okay. There wasn't anything wrong with the system. What happened was that they liked this unit, but they needed to carry it around. So they put it in a case, okay? And the case, how many of you guys know how to reset a 75? You have to hit, attention, shift, and something else, delete, I think it is. Okay, there are 3 different edges of the thing. Well, this case, okay, it turns out was pushing on all of those buttons just right so that intermittently it would reset. Had absolutely nothing to do with the unit. It had to do with their fancy case that they put it in, and we put a plastic shield on top of it to keep it from pressing the buttons.
So that's the standard case, design help. Is that the case?
It's not the black one. It's the green. It's a green corduroy type case. Yeah.
I do have a question for the old HP people here. I've been very particular on all the calculators I've worked on to try to replicate the on B, because I'm an old 48 guy, on B, on C, on AF type of key combination, and on E. We still have them in prime. If you do on SIM, on app ESC, it does the same as you would expect. Where does that come from? What are the first calculators that did that?
It's the heritage.
I don't know. What we did is on the 75, where that came from was we wanted to make it as difficult as possible to reset. So we did basically 3 corners of the keyboard.
Is that
And-
the first
and-
calculator that you used?
I don't know. Yeah.
The Titan and the Kangaroo were developed concurrently almost, right?
Yeah, I think the RU was just a little bit, well, the RU was actually developed at HP Labs first, and then transferred up, converted into CMOS and whatnot. So the hardware stuff started earlier, it was older. But you're right, the products themselves came out, I think you guys would know more about the release dates than I, but it was more or less concurrently and very competitively.
Yes, we've heard that.
Yeah.
Have you heard of a report of users coming to the factory to evaluate RU? They were at a hotel and all the accessories and everything was brought to them, and with the 3-day beta testing, debugging. You ever heard that?
No, not specifically. I was just a hardware weenie, so you know. Okay, so by the way, when we took this to production, I did something unusual at the time. As I raised my hand and I said, I want to go to production with this. I was the lead architect for the pod, and I said, I want to go to production with it. I want to just find out how we build it on the line and whatnot. And we were building this thing in 3 shifts. You know, we had graveyard, swing, and day. And one evening I went in to graveyard shift, and they were looking around. Who are you? And I said, well, I'm the engineer that worked on it and whatnot. I'm production engineer for it. And they said, we've never seen an engineer before. Graveyard had the luxury of being pretty shielded from the day-to-day, like day shift always got interrupted because managers or engineers or somebody would come along and ask them questions or check to see how things were going and that kind of stuff. Nobody ever saw Graveyard though. So one time on Graveyard, I went in a couple times. One time on Graveyard, we had what we called a 3060 tester. It's a board tester. It used pogo pens to come up and test this main PC board. Okay, so I didn't write the program. Dirk Bodley did. I remember his name. He was the production test tooling engineer. And the reason I remember his name is going to be obvious here in a second. So I'm going through. I don't know if you guys have seen decision tree stuff in maintenance, but basically it says do this, and if this happens, then do this. This happens, do this, and that kind of stuff. Okay, so I said we were having a problem with a board, and I went do this. Okay. The tech that night couldn't figure it out, so I was sitting down with him, and it says, do this, yeah, do this, that, yeah. So about 5 pages into this, I come to a phrase that says, I don't think anybody ever uses this documentation. So if you get to this point, would you please give me a call? And it had his phone number in it. So what did I do? I gave him a call. We figured it out the next day.
First person ever.
But it was one of those things. Well, I don't think anybody ever uses this stuff. So, okay. So my next assignment after that was to become a manager. So I went over the dark side, and my first project was the single chip Series 10. Okay, so we'd already been in production with a 2-chip version of the Series 10, where one chip was the CPU and the second chip was sort of like everything else, RAM, ROM, keyboard, display, and all that other stuff. There was a project to do a single chip version, and that was our project. Okay, at the time, there's politics everywhere. At the time, there were 2 HP divisions. There was the PCD, the calculator division, and there was the components division, which was doing the chip design. That's the one I joined to do this project. Okay. When I come in, they tell me, by the way, the components group promised the calculator guys that we would have this single chip version 6 months ago. So you're late. Okay. and you really need to catch up on your schedule. Okay. You guys have probably all had this happen to you in your career. Ironically, it wasn't that long since Return of the Jedi came out. Okay, how many of you guys remember the initial scene in Return of the Jedi? Okay, Darth Vader comes in, he lands on the Death Star that's under construction, and he walks out and he meets the station commander, and he says, the station commander says, well, we're a little bit behind, blah, blah, and he stops and says, I'm here to get you back on schedule. And I definitely, in my first role as manager, felt really like that. I was put in that kind of situation. They said, come in and do this. Now, the single chip version, one of the differences between this one and the previous one is we were using standard cells for the first time. Okay, before this, the Series 10 stuff was handcrafted custom artwork. That means they didn't have gates that they replicated. Every gate was drawn, the geometries of that were all drawn individually. It was an E-size schematic. What we started with was a paper schematic, which we weren't sure was right. Okay, a paper schematic that was the chip. It was signed by Grant Garner. He was the lead engineer. Okay. So our job was to take that schematic. We had that, and we had the test program, which the test program we were running it the part in volume, so it was less than 20 ppm. It was really high quality stuff for the time. Okay, so we thought that together with that, the test program gave us the ROM, because one of the things it did was it checked the ROM. So we had the ROM, and we had that, and we had the schematic, and that's what we built the chip with. Well, couple things. First, an acknowledgement. Eric Gullerud, Alan Brown. We brought a Singapore team in. We had a group of 5 engineers from Singapore. One of them went on to he's the site lab manager in Penang for HP, then Agilent, now Avago. We've got Chong Frederick is one of the site managers for one of the groups in HP in Singapore now. So these guys were really good. We were all young. We were all absolutely stupid and crazy. We worked 12-hour days, 7 days a week to get that part out. Okay, it was, but in retrospect, it was a blast. We actually pulled it off. Okay, so when we got the first parts back. So we had done a lot of testing. Okay, we had done as many regressions as we could. We did a build, and this is a collector's moment. Okay, we did a build of the 12C. Okay, and we built, I forget, it was several hundreds. It's in the hundreds. Okay, of these calculators. Okay, and one of the last tests we did was we had a group of operators go through and do all of the examples in the 12C manual to make sure they worked.
Jeez.
Okay, well, it's a good thing we did that. First time an operator get on, period, commas went all the way across the display. There was a logic bug in the part that we hadn't caught. Okay, and so there are several hundred of those 12Cs out there in the world. Okay, what happened is we didn't sell those to customers, but we kept them inside HP. Okay, and we kept them in a lock cabinet, and when somebody needed a calculator, we gave them one of those because, inside HP, because it worked unless you were in Europe, right? So that was one of the fun things. The other is when we were doing the standard cell design, it was a royal pain to hit our die size with these standard cells the first time through. We used a program called SCOPE, Sandia Controllability and Observability Program. It's something that basically looks at how testable your stuff is. When we did that this is after we got the part out and released, when we ran that, we found that there was a significant portion of the gates in the design that when we traced it back, there was a NAND gate that was tied off locked. Okay, and so this whole piece of the logic wasn't used. It was blocked off because this was leveraged off of something that was leveraged off of something that was leveraged. And this was used in a CPU in a product several times ago, and there was no note anywhere that this whole piece of the logic wasn't used. So we laughed at that a little bit when that happened. Okay, so went on after Single Chip Series 10. The team I worked with did Lewis, Sacagawea, Burt, Clark, all basically the chips for the Pioneer products. Then we went on to do basically designs for all of HP. So we did designs for the Greeley plotter the Greeley tape drive folks, the Colossus, and I forget what the other name was of theirs. It was a really neat product. We did chips for a lot of the Vancouver printers, the inkjet printers, the San Diego photo printers and the plotters. We did some of the mini computer stuff. Sterling was an architecture out of the labs that we did. So this group basically had a lot of fun doing designs for all of HP. And HP is a great place it's still a great place for engineers in terms of being able to contribute in a large number of different places. I've still got friends over there. Now, so where are we now? Well, I'll ask you the question: what do calculators, DRAMs, and CMOS image sensors all have in common? No. Okay. Well, it turns out that HP, when we did the calculator designs, the CMOS process that we did has a very low leakage current, and the reason for that is so that you get long battery life. There was a story that's very true. I've got my site admin worked in HP service. She confirmed with me that this was true. I thought it was just a tale. That we did get the 12C calculators back, okay, after they've been out for years, okay, and because they stopped working. And what was wrong, the only thing wrong with them is that their batteries had died after a few years of use. And people didn't realize that their calculator actually used batteries. Okay.
Imagine that.
So, low leakage CMOS process, okay. Also, by the way, DRAMs also need low leakage for memory retention. Okay, Micron got into the CMOS image sensor business because that low leakage stuff worked for DRAMs, works for sensors. HP got into the sensor business. Okay, by the way, do you guys know one of the reasons why HP got into the digital camera business? or why Japan, let's back up, why Japan got in the digital camera business originally. Close. It was an excess capacity problem. For one of the Olympics, they built up a lot of cellular network bandwidth, and they couldn't figure out how to use it all. And they figured if they started putting cameras and cell phones, the image transfer across the network would start using up some of that bandwidth capacity. So it wasn't any, it was only people trying to figure out how to sell you more cellular time that started up the digital stuff. Now, from an HP perspective, one of the reasons why HP was interested and went into the digital camera business for a while? Printing. Because there wasn't enough color content to generate ink usage for the printing. And so there just wasn't a whole lot that, if you think back, there wasn't a whole lot of content that would use up color ink. And so digital photography was perfect for that. And by the way, one of the chips that our guys did was called Motherlode, and another was Goldilocks, and they were the chips that went into the digital cameras for HP. So the group I'm working with now, we're doing CMOS image sensors for a company called Aptina, where we do them for cell phones, for backup cameras for cars, for surveillance, for medical, all that kind of stuff. And by the way, it's some of the same guys. Eric Gullerud, one of the people that worked on the single chip Series 10, is working on the image sensor stuff now. Don Reed, who had worked on a number of the parts, the 71 and that kind of stuff, is on the team and that kind of stuff. So we're getting old, but we've still got some of the old team around. Okay, that's all I had. Is that okay?
Perfect. Thank you.